Consider this chicken. Every time the chicken sees the farmer, it's because the farmer is coming to feed her. It's happened hundreds of times. Once again, the chicken sees the farmer and, bursting with excitement, the chicken anticipates her dinner. The farmer picks up the chicken, breaks its neck, and serves her up for his dinner instead. What if I told you we're all like the chicken? Can we prove anything at all, or is all our past experience useless in proving what will happen in the future? To answer that, we need to look at two types of reasoning: deduction, which can prove things when done properly, and induction, which is essential for science, but like the chicken, it has a big problem. Let's start with deduction, because if anything counts as proof, this is it. A deductive argument is an argument in which the conclusion necessarily follows the premises. For example, all men are mortal, Socrates is a man, therefore Socrates is mortal. Here, the conclusion logically follows from the premises. As such, we can also say this is a valid deduction. If the conclusion did not logically follow, it would be an invalid deduction, like this. All men are mortal, Socrates is a man, therefore all men are Socrates. Here, we've made a mistake. The conclusion is not a logical consequence of the premises, and our deductive argument is invalid. Because a deductive argument is simply a matter of logic, as long as it follows the same pattern, the deduction will be valid. We can represent it a bit like a formula. All A's are B's, C is an A, therefore C is a B. This isn't the only way to have a valid deduction, but it's one possible form. And this is amazing because if we replace A, B and C with anything, it will always be a valid deduction. But what if you replace A, B and C with complete nonsense? Would it still be valid? Let's say all snails are athletes, Donald Trump is a snail, therefore Donald Trump is an athlete. Now, one thing's for sure, snails are not athletes in any sense of the word. Is Trump a gastropod? He doesn't appear to be. The premises are clearly false, but validity, as so far defined, doesn't care whether the conclusion is actually true. It only cares about the logical consistency of the argument. This is a valid deductive argument. But what we can say, if we compare this argument with the original Socrates one, is that the Socrates argument is sound and the Trump argument is not. An argument is sound when it is both valid and factually correct in the premises, and consequently in its conclusion. So what if Trump became an athlete and competed in the Olympic Games? Now our conclusion is true, but even though the conclusion is true, the argument isn't sound because it's derived from factually incorrect premises. If that's our argument for Trump being an athlete and Trump is an athlete, we're only right by accident. The argument as a whole is wrong. So with deductive reasoning, an argument is valid if the conclusion logically follows from the premises and invalid if it doesn't. An argument is sound if it's both valid and its premises are factually correct. What's more, an argument that is valid and sound is also called a proof. So this is what proof looks like: a valid argument with true premises where the conclusion has to be true. But most of the time we're not dealing with proof like this. Arguments aren't always this perfect. Sometimes we end up not with a guaranteed conclusion, but a conclusion that is probable. These are inductive arguments. For example, studies show that smokers are more likely to develop cancer than non-smokers. Therefore, smoking increases your risk of cancer. Notice what's missing here. This isn't a proof. The conclusion doesn't have to be true. It's just likely given the evidence. And this is because such reasoning moves from some observed matter of fact, a correlation between smoking and cancer, to draw conclusions about some unobserved matter of fact. If you start smoking, you'll increase your risk of cancer. Obviously then, inductive reasoning is essential to science. But there's a problem. Remember this guy? The chicken's mistake? The chicken is assuming the uniformity of nature. She's assuming that the future will resemble the past. But the probability or certainty of something happening in the past is no guarantee for it so doing in the future, as the chicken tragically learns. As Bertrand Russell says, more refined views as to the uniformity of nature would have been useful to the chicken. The chicken didn't have proof that the farmer hobbling towards her meant what she thought it did. But it's not just the chicken who has a problem. All inductive reasoning rests upon the assumption that nature is uniform. Is this assumption justified? Because if it is, there's nothing to worry about. All inductive reasoning has a firm foundation. The problem is that the principle of the uniformity of nature is itself only justified by inductive reasoning. We have always observed nature to be uniform, therefore nature is probably uniform. The supposed justification of inductive reasoning is itself an inductive argument. The entire support system is circular. So, if induction can't be justified, then a lot of what we take to be knowledge isn't proven at all. This problem of induction was highlighted by David Hume, the great 18th century Scottish and empiricist philosopher, who argued that our knowledge is constrained by our experience. We do not have experience of the future, so by definition, our experience of the past cannot translate into knowledge about what hasn't happened yet. Just because the sun rose every day in the past doesn't mean it will necessarily rise tomorrow. The whole laws of nature could be flipped on their head tonight for all we know. So, deduction gives us proof, if we do it right, and induction might just be us making very good guesses. But do you think that's enough? If you enjoyed this one, share it with your philosophy friends and give it a like. Thanks for watching and see you next time.